Alright, this video is basically another simulation that I think that if you worked carefully about it, you could make it into a game, or you could use it to like spawn conversations that are game-like. The reason why I'm picking this is because in, I believe, the Beecher article, Marino and Beecher article, we talked about the ability to, modify an assignment to adapt to the abilities of different learners, especially in a science classroom. So I wanted to show this particular idea or this particular simulation. One thing that I really liked about this stuff from this particular webpage is they let you embed these simulations on a webpage. So I don't know about you guys, but it's a lot easier if I can embed it into a web page and a kid can link on a device a lot easier. Sometimes they can do it on their phone. Other times they have to have a tablet. But just being able to like click on it from a web page is sometimes easier than opening a link and downloading an application and all that. All right, so here we go, the Pendulum Lab. All right, the thing that I really liked about the Pendulum Lab, and they've got like an extension to it, and I'm not pretending that I'm a physics teacher, but there's certainly aspects of this thing that I really like. I like the fact that you have the ability to move this like ruler around, to have a discussion about, okay, how long's the string? Okay, the string is this long. Okay, you can adjust the length of that string. You can say there's impact for that. How far, I wish that you could rotate this. The fact that you can turn a timer on. You can put the period trace on. I'm just going to show you, okay, first of all, we can see the ruler. Okay, now, another nice thing is they let you they talk in terms about, okay, where's that thing being moved? And they treat to the left like physics teachers to the left. It's negative degrees. So when I let go of this, it's starting a pendulum swing. Now, unlike a real pendulum, that this would eventually stop moving, this will go on forever. Okay, another nice thing about this is, okay, this is how it would be, this is how the physics world interprets what this would look like. But this will let you have a better conversation with students about what's happening. Okay, it's reaching its apex. You can measure these things. You can pause it. And you can say, okay, it's almost there. It's almost there. Okay, where are we at? That's how high I would swing. Okay, these are all good points of having a discussion here. Now, look at this stuff over here. We've got the ability to augment stuff over here. So, like, if I do this, we can change that, and then we can talk about what's the impact of that change. And since I want to see it in the normal speed, okay, did that change its oscillation? Because oscillating is what it's doing. And since we're talking about oscillation, okay, there's the oscillation. As a trick teacher, this is how I'm going to get this to be a sinusoidal function. Because kids have a hard time seeing that this would be a sinusoidal function, but it has a max and a min. Now, in reality, a pendulum would be a dampened oscillating function because eventually that it would stop moving back and forth. Because if we could get a perpetual motion machine, we would certainly not need fossil fuels. Okay? All right. There we go. That's what that happens. And then, whoa, what's the impact of this thing right here? What happens if it's heavier? Well, if it's heavier, or more importantly, what would happen if it's lighter? Can we see there is a definite connection between changing mass? Well, maybe not as much with one. Okay, and then, okay, what's the impact of gravity? If I have a lot of gravity, then that's what happens. Or what happens if it didn't have a lot of gravity? Well, look, it could possibly escape. Like, that's none. Well, what's none mean? None means that there's going to be nothing that's going to prevent nothing causing it to pull back down. All right. Another thing is, like, you can see, and then you can time the period of the oscillation, and that could be used in a trick class in their respect to, like, okay, how can we model the behavior of this pendulum using a function? Okay, and why would we want to think of this function as sinusoidal? Okay, now over here, we also have these added things that math teachers hate to think about. Like we think our lives are hard enough when we have like 2 variables. But right now we've got so many variables on here, it's ridiculous. Okay, I can customize this. We could talk about, this is probably more like being on the moon. This is what it was like being on Earth. Okay, Jupiter. And then you can have a discussion why gravity would be different on these different planets. Has something to do with mass. Okay, planet X. What's the value of my gravity? They're really trying to see, do you understand what planet X is all about? And then custom. Done. See how slow it goes. Gravity's not impacting the swing. Lots. Gravity's impacting the swing. And then the average is there. Alright, now this is a case where your game could be, how many questions could you come up with that we could study in class about this pendulum? Or better yet, what would happen if we had 2 different pendulums? Okay, and we started swinging them from a different spot. And okay, one's really light. Okay, and let's go back to Earth's gravity because we do live on planet Earth. When would they be at the same spot? Because these things will eventually cross each other's path. Like, they'll be back at the, like, I guess, point of demarcation more frequently than you would like to know. And then, okay, this is showing that this would eventually slow to a stop. So I guess I just never watched the function long enough. Okay, so this is truly a dampened trigonometric function there, but that's not a discussion I'd really want to like get into right away. I mean, that's a pretty high level discussion. So I'm going to stop it. And then let's start it back up again. All right. Reset the timer. Turn it on slow. Adjust the lengths to be, oh, I don't know. Let's see what happens if we make the lengths the same. We're close to the same. And what would that mean to my sinusoidal graph? All right, why are they overlapping each other? There's lots of potential for this particular like simulation. So while not game-based, I still think that it's challenge-based, and I mean the games are supposed to be a challenge. Okay, there's a lot of simulations for this particular like software application. All right, thank you for watching my video.